In this video, I will be teaching you how to find a discrete Fourier transform. So DFT is actually one of the transform out of many. And even to find a DFT, there are various ways you can solve. And I'm just going to, start with one of the method. So let me just take one question. And the question is, we are supposed to find discrete Fourier transform. That's a short form of DFT, of x of n. Now we have a signal given to us, and x of n is 1, 2, 3, and 4. And we're supposed to find DFT. Actually, this can be done in various ways, but I'm showing you the main method. So if it is a question in exam for like more weightage, say 4 marks or 6 marks, then you have to solve properly with the help of the using the formula method. And that's the first method that we're discussing here. So let me write down, this is method 1, most comprehensive method, a complete method by using a DFT formula. Okay. So now, first we should have a look at what is x of n. Now, whenever I say x of n as 1, 2, 3, 4, it is clearly a discontinuous signal. So let me plot so that you understand how exactly this x of n is. This is n versus x of n. And if I plot, the values are 1, 2, 3, 4. So you have 1 and 2, 3, and 4. These are the values of x of n. Now, the first one value is at n equal to 0. Okay. So this value is n equal to 0, right? This n is a horizontal axis. And at n equal to 0, the value is 1. This is at n equal to 1, it is 2. At n is equal to 2, it is 3. And at n equal to 3, it is 4. Now, see how we write it also. We write it like this, that when we say x of n at n equal to 0, okay, we can simply put n0 in here. Okay. So this will become x of 0. And x of 0 is going to be 1. Okay, that's how we write it. Well, let's write one more. So if I have x of n at n is equal to 1, I will write this as x of 1. And the value of x of 1, now you should just see at 1, the value of x of n is 2. So the x of 1 is 2. I hope you followed this. So x of 2 is going to be 3 and x of 3 is going to be 4. This is only for your reference. Okay, we will need this later on. Now, as I said, we're going to be using a DFT formula. So let me write down the formula of discrete Fourier transform. This is by DFT formula. Let's write down the formula now. X of k. Now the formula says if you want to find out x of k, which is a DFT of x of n. X of k, let me write DFT of x of n. Okay. And then the formula of DFT is simply sum. N will go from 0 to n minus 1. Now understand, n is 4 right now. N is basically length of x of n, and that is 4. So this number will be n minus 1, which is 3. This is x of n, and this is w, not omega. This is w n raised to nk. Now this is called as a twiddle factor. Okay. And there is a formula to this twiddle factor also, that wn raised to 1 is e to the negative j 2 pi over capital N. You can say j or I. Basically, that's an the complex part. Okay, I or j or iota, whatever you want to call it. Anyway, so we wrote down the formula here, and now let us start solving this problem. This n minus 1 value is going to be 3, right? So now if I have to write down this x of k, okay, n is going to go from 0 to 3. So for n is equal to 0 to 3, let us substitute values in this equation, and let's see what we get. So we will get x of k is equal to, okay, if I put n is equal to 0 in this, let's just write down this properly. This will become x of 0. Look, I'm putting n as 0. Okay, this will become wn raised to 0. Wn raised to 0. Now let us put the next value. N is going from 0 to 3, you see. So we put n equal to 0 first. Now we're putting n is equal to 1. So it is going to be x of 1 wn raised to 1k. Okay, then when we put n is equal to 2 here, this will become x of 2 wn raised to 2k. So let me write that. This is x of 2 wn raised to 2k, and the next one will be x of 3 wn raised to 3k. So I basically got one expression for x of k. Now this is going to be my main expression. So let me highlight this a little bit. And from this expression, we will now write this down nicely. See, this will be, let us write down the values here. Tell me what is the value of x of 0. Now x of 0, if you see here, simply means the value of x of n when n is 0. When n is 0, the value of x of n is 1. You see that here? So this value is 1. Okay, we know that any term power 0 is going to be 1. So this is also 1. And the value of x of 1 is 2. Do you see that here? I hope you get that. This is 2, then 3, and then 4. So let me write down this is 3 and this is 4. So let us write down this in a simplified form. So I get x of k as, now the x of k value will be this term, the first term will become 1. Then next is 2, this is wn raised to k. Then next one would be this is 3 wn raised to 2k, and the next one would be 4 wn raised to 3k. Is that correct? So we got an expression for x of k like that. Now as soon as you get this, we will rather use this expression. This is more simplified than the first one. So once we get the simplified expression of x of k like this, now we will put different values of k. So we will put the first value of k as 0. Okay, let's see what happens. When I put k is equal to 0, this x of k will become x of 0. Okay, that is equal to 1 plus 2. This is wn raised to 0 because I'm putting k 0 in this case right now. And then this will be 3 wn raised to 0, and this is 4 wn raised to 0. So when I put all these values, wn raised to 0 is always 1. So basically I get this as 1 plus 2 plus 3 plus 4. And if you add them all, the answer is going to be 10. Okay, so I got the first answer, the first value, and that is x of 0, and the value is 10. Okay, now as soon as I get the first one, now let's go on to k is equal to 1. That's the next one that I'll put. When I put k is equal to 1 in the main equation, this is 2 hashtag equation, this one here. So this will become x of 1. So I'll write x of 1 is going to be 1 plus 2 wn raised to, I'm putting k as 1. So this will become wn raised to 1. Next is 3 wn raised to 2 times 1. Okay, we have to make k 1. Okay, this is 4 wn raised to 3. Now once I get this as an expression, we will have to use this. Do you see wn raised to 1 over here is e raised to minus j 2 pi over n. So let me write that down here because we will need that value here, right? Okay, we'll replace that value here. So what is that going to be? wn raised to 1 is e to the negative j 2 pi over n, and this capital N is 4. Okay, and the 4 is the length of a signal, and we have right now our x of n is of 4 length. So we'll put n as 4, and then this will become e raised to minus j pi over 2. That's 2 to the 4. So once I get it like this, there is a Euler's relation or the Euler's formula. And let me write down that formula real quick over here. I hope you remember this from mathematics, that if you have e raised to I or j theta, whatever you call it, this will be cos theta plus j sine theta. This is a famous Euler's relation. So if you have a plus sign here, you write down plus sign here. Or if it is negative over here, then you write down negative over here. And we have negative, right? So how will we express this? This is going to be cos of the theta, the angle is pi over 2, minus I or minus j sine of pi over 2. Now we know that sine 90 is 1 and the cos 90 value is 0. So you will get this as 0 minus j. So we got the first answer here, that wn raised to 1 is minus j. Okay, and we can use that value over here, and this becomes minus j. Right, now once you find wn raised to 1, the next thing we want to do is you want to find a wn raised to 2, and this is rather simple. You can write it like this. This is wn raised to 1 square, no? So if I just take wn raised to 1, the value is already minus j, and if I square it, it is going to be minus j the whole square, which is nothing but the minus will go away because we are squaring it, and the j square is going to be minus 1. So from here I get wn raised to 2 is minus 1, isn't it? So I found out wn raised to 2 and the value is minus 1. So let me write that. Now next I want to find out is wn raised to 3, which is, I can write it as wn raised to 1 times wn raised to 2, and we have both the values. wn raised to 1 is minus j and wn raised to 2 is minus 1. So we'll just multiply the two. You will get this as minus j times minus 1, minus minus becomes plus, so you get this as j. So wn raised to 3 is j. Well, so I got all these values over here, and now I just have to solve and to get x of n. So let me clear some space on the left hand side. Like we can just delete this now. So the x of 1, so the x of 1 is going to be, this is 1 minus 2j, 1 minus 2j, then this is minus 3, do you see? 3 times minus 1 is minus 3, and 4j, this is plus 4j. Okay, so let us write x of 1 properly. We can add real values with the real one. So 1 minus 3 gives me minus 2, and minus 2j and plus 4j gives me 2j, isn't it? So that's the value of x of 1. So I found out the second value. First one was x of 0, and the next value is x of 1, and x of 1 is going to be minus 2 plus 2j. Now, before we move on to the next one, I just want to tell you a quick shortcut. Okay, now just pay attention to what I'm saying. That if you want to find out these values, okay, like the wn raised to 1 or wn raised to 2 and wn raised to 3, which is j. Now to find this, you can use actually a simple technique, and then there is a shortcut technique. Okay, I just wanted to show how that working is, but then in exam you can always use this method and find out these values. So how we do it is, this is the real axis and this is the imaginary axis. I'm talking about a complex plane right now. So you have real value is 1 and minus 1, and imaginary value is plus j and minus j, isn't it? So what we do here is, you can start from here, okay, and this value is wn raised to 0, okay. Then you go like this, okay, go this way, and the next value is wn raised to 1. Do you see wn raised to 1 is minus j? Now just keep going like that. Then wn raised to 2 is minus 1. Do you see it's working? And then wn raised to 3 is going to be j. wn raised to 4, you can actually keep going like that. wn raised to 4 is 1. wn raised to 5 is minus j. wn raised to 6 is minus 1. wn raised to 7 is j. wn raised to 8. wn raised to 9, and on and on and on. You can just like keep going. Okay, and that way you can find out these values much quicker. Okay, and just note one last thing, that you will use this diagram only when your n is 4. Okay, now that's the point to be noted. Why? We will get to that later. When we have 8-point sequence, when you have 1 2 3 4 5 6 7 8, okay, that's coming up. Okay, the diagram will change. I'm sure you can guess, but right now just remember that you can use this technique only when it is a 4-point sequence, or when the length of a sequence is 4. Okay, but nonetheless we can use it right now, and let's continue solving. So where were we? We did k equal to 0, we got x of 0. We put k equal to 1, we got x of 1. Now we'll put k is equal to 2. Let's see what happens. If I put k is equal to 2 in the double hashtag equation over here, this will become x of 2, right? X of 2 is going to be equal to 1 plus 2 wn raised to 2. I'm putting k equal to 2. Now tell me the next one. Tell me what will that be? 3 wn raised to 4 and 4 wn raised to 6. Okay, and now this time I want you to get these numbers from the diagram over here. Tell me about wn raised to 2. wn raised to 2, you can see here, wn raised to 2 is minus 1. Okay, wn raised to 4, okay, you can see that here, wn raised to 4 is over here, that is 1. And wn raised to 6, this value is going to be, okay, wn raised to 6 is over here, so that value is minus 1. Okay, so once you put these values and simplify, I'll write this as, this is x of 2, that is going to be 1, 2 times minus 1, minus 2, then 3 times 1, 3, then next is 4 times minus 1, minus 4, and then the final answer is minus 2. Is that correct? 1 minus 2 minus 1 plus 3 is 2, and 2 minus 4 is minus 2. So we got x of 2, and x of 2 value is minus 2. Let me write that. X of 2 is minus 2. Now, one last thing we have to do is substitute k is equal to 3. Okay, so just note one point, that in the original signal x of n, the values of n are going from 0, 1, 2, and 3. Look, the x of n itself is 4, having a length 4. So the n will go from 0 to 3. And so the k will also go from 0 to 3. That's why I have taken the first value of k. The range of k and range of n is going to be same. So first value of k is 0. The next value is 1, the next value is 2, and the next value is 3. Okay, so I'm putting the last value right now, and we will see what we get here. This is going to be x of 3. Okay, let's quickly put k equal to 3 in the double hashtag equation over here. So I'll get x of 3 is equal to 1 plus 2 wn raised to 3 plus 3 wn raised to 6 plus 4wn raised to 9. Okay, and let's write down x of 3 real quick. What is the value of wn raised to 3? We can look from this diagram. Wn raised to 3 is going to be j. So I'll get this as 1 plus 2j. And what happens to wn raised to 6? Wn raised to 6 is minus 1. So it is going to be minus 3 here. And wn raised to 9, this value is minus j. So it is going to be minus 4j. If you solve, the answer is going to be minus 2 minus 2j. Okay, now that's the value for x of 3. I got minus 2 minus 2j. Now finally what we will do is we will write down this answer properly. So I will have to make some space again. Let me clear some space here. So let's just say the final answer, okay, which is x of k, that is a DFT of x of n that we have obtained by using the formula. And the final answer, the first value we got was 10. This was for k is equal to 0, right? So this is for k is equal to 0. I'm just writing vertically just to make it look proper. I just deleted this value here. I hope you remember this was x of 1. Oh, it's over here. So x of 1 is minus 2 minus 2j. That is over here, minus 2 minus 2j. This is what I've got for k is equal to 1. And for k is equal to 2, I got x of 2 is equal to minus 2. So for k is equal to 2, x of 2 is minus 2. And for k is equal to 3, x of 3 is minus 2 minus 2j. So it is minus 2 minus 2j. This is k equal to 3. And this is how you get the final answer. And this is pretty much the method how we find discrete Fourier transform. This is the answer, discrete Fourier transform of a signal. Okay, and this method will work very, very well when you have n is equal to 4. And as I said, this is clearly method 1. Okay, the long cut method, so we can say, because we're going to have some shortcut. So I'll show you the second method. We will solve the same question. We'll get this answer much faster. Okay, so that's coming up. So now we'll go for the second method. Now method 2 is a lot simpler than the first one, and we will get the answer also very quick. And this is by using Dft Matrix. Okay, so see how that works. That you want to find out x of k, that is a DFT of x of n. So we can write x of k like this. X of k is equal to, now you can use Dft Matrix. Now after looking the long cut method, we will really call this is a magic matrix of DFT. Anyway, so we have x of n, values are 1, 2, 3, 4, which we'll write down over here. Now these are x of n values. Okay, 1, 2, 3, 4. Now once we write down these values here, you have to remember the DFT matrix, because this comes in handy when you want to find out DFT of sequence like a 4-point sequence. And just remember that this is all going to work only when your n is 4. Okay, so what if n is other than 4? We will discuss that when it comes. As of now, let us focus on how to find DFT of a sequence that is having length 4. Okay, so the way we can write DFT matrix, just remember this also. The first column is 1. So you write 1, 1, 1, 1. And the first row is also 1. So write down all ones like this. And all you have to remember is this minus j. Okay, so the value over here is minus j. And then once you remember that, it's going to be very easy. The diagonally, now this is how I ask my student to remember this. The diagonal opposite value is also minus j. So it is minus j over here. Then it is plus j here. And diagonally opposite, you will write down plus j. So start with minus j, diagonally opposite minus j, then plus j, and diagonally opposite plus j. Okay. Once you do that, next you will make one diamond shape like this of ones. Sorry, of minus 1. So it is minus 1, minus 1, minus 1, minus 1. And in the center, you write down 1. That's just the way I remember it. So first row and first column are all ones. Then remember that this value here is minus j, diagonally opposite minus j. Then it is plus j here and plus j here. Then make a diamond of minus 1s and center has 1. Okay. Now once you write down all these values, you just simply have to multiply these two matrices and you will get x of k. Okay, so just see how that works and we'll get the same answer. Now, multiplying a matrix is always done row. The first row will multiply with the column here. So it's point by point. The 1 will get multiplied with 1, 2 with 1 with the 2, one with 3 and one with 4, and then we add them all. So it is going to be 1 plus 2 plus 3 plus 4. Now we go for the second row, okay, over here, and this column. The second row values are here. You will multiply them with this. So it is 1 into 1, which is 1. Then minus j into 2, which is minus 2j. And when we multiply minus 1 with 3, it is minus 3. And j with 4, it is 4j. Now next is this third row with the column. It is 1 minus 3 plus, 1 minus 2 plus 3 minus 4. And the last row you multiply with this column. It is 1, and j times 2 is going to be 2j, and then minus 3 and minus 4j. So there you go. And let's just simplify these values here. So 1 plus 2 plus 3 plus 4 is going to be 10. And then 1 minus 3 is minus 2. Just deal with real and add imaginary with imaginary. So it is plus 2j. And then 1 minus 2 plus 3 minus 4 is minus 2. And it is minus 2 minus 2j. We've got the same answer, but much quicker, much easier way of solving. Basically, it's the same formula. That is, the DFT formula is expressed as in matrix form. Okay, it's no big deal. But then when you have a question where you want to find DFTs very quickly, you can always use this technique. And as I told you already, that this method, or of course this matrix, will work only when you have n as 4. So if your sequence has got 8 points here, these two matrices are just cannot be multiplied. So in that case, you will definitely not be able to use this. So you can say DFT matrix or magic matrix, but then works only for when you have a sequence of length 4 and not anything else. Okay, but then nonetheless, we will have this as a easier method to find out DFT of a sequence like x of n given to you here. So there are a few other methods also, but as of now, we're just going to stick to the method 1 and method 2. Okay, when we will next do fast Fourier transform, we will see a few more methods of finding the value of x of k. Okay, so that is all when we do FFT. But as of now, this is how we can find out discrete Fourier transform of a signal which is a 4-point signal whose length is 4. Okay.